Hey guys, welcome to today's lesson, the third lesson in the series of modelling linear relationships for the General 2 HSC course. Today we're looking at applied questions. You're going to get questions where instead of having an X and Y axes, you might have different letters on them. For example, you could have N for the number of months, you could have C for cost. And you might be given a line such as this, and obviously you could be given values. For example, that could be 50. You might have another value here which would be something like 10 and let's say 60. And you're asked to find, it might be the cost when N is 10, which would be 60, or the cost, so the number of months there are when the cost is $50, which would be 0. Or of course I could ask you to find the equation in the terms of y equals mx plus b, but of course you wouldn't have the y and the x because you don't have a y and x axis. You have a c and an n axis for this question. You'd still have to do the same sort of things by like finding the gradient, for example, doing my rise over my run, which would be 1 in this case. And then my b in this case would be 50, but then I'd replace it with c for the y value, and we'd have 1n plus 50. And you come up with an equation that's, I guess, is a bit more applied. Of course, that could also equal c equals n plus 50. So there's sort of the questions that we'll be looking at, all right? So we're going to look at a question now. The graph opposite is used to convert Aussie dollars to New Zealand dollars. Use the graph to convert. So A says 40 Australian dollars. So here I'm going to go up, and to convert them into New Zealand dollars, we get 50. So the answer for A would just be 50 New Zealand dollars. So nice and simple. Part B, just as simple, 25 New Zealand dollars this time. So halfway between 20 and 30. Go through until I hit that point, we get 20. So I get, in this case, 20 Australian dollars. Now I've added a couple of questions in here as well. So for C, find the equation in terms of A and N. Well, y equals mx plus b. My gradient will be my rise over my run. So I'm going to look through here. I'm going to start at the 0 because that's nice on the point. I'm going to actually use this line here, and I'm going to draw my big right angled triangle and looking at my rise over my run. My rise is 50, my run is 40, so my m equals 50 divided by 40, which equals 5 over 4, or you could put it as 1.2. Okay. Now, so 1.25. Be careful then. All right. Now for my y-intercept. My y-intercept, you can see, is at 0. So I can replace that and say y equals 1.25 x plus 0. Well, I don't really need to put the plus 0 there, do I? So I can take that off. But now I need to replace the y and the x with n for New Zealand dollars and a for AUD. So the y is on the y-axis. That's n equals 1.25 and a for that axis, and I've got my formula there. Of course, you could put that as 5 over 4a as well. And our last part there, which is often the really challenging question people struggle with for D, what does the gradient represent? Well, gradient represents the rate of change between New Zealand dollars and Australian dollars, but I need to kind of apply that a little bit more. What does that mean when you're going from one currency to another? Well, it represents the exchange rate. The exchange rate. Okay. If you put the rate of change between Australian dollars and New Zealand dollars, then you might be lucky enough to get away with it, but certainly the exchange rate is a bit sort of more meaningful. Next question about Grace, who's selling insurance. She has a base salary and a commission on each new insurance policy she sells. Grace's weekly income, I, depends on the number of new policies, N, she sells in that week. So part A, what is her base salary? Well, that's when she doesn't sell any policies. That's 0. Go up to 400, so it's $400. They might have asked you different questions such as what does the y-intercept represent, and you would have said her base salary. But okay, that's our first question done. B, what is her salary in a week? She sells 8 new policies, so I go up to 8 across, we get $800. C, how many policies does she need to sell in order to earn $700 for the week? Well, that's going to be between 6 and 800. I go across till I hit my line, go down, we get 6. So 6 policies. Now for the more challenging question. D, find the equation in terms of I and N. Well, y equals mx plus b. My gradient, I'm going to find by looking at the rise over my run. I'm going to use that point there and that point there. You could even use one of these other points that are exactly on, but those are fine. 400 to 600 means it's the rise is 200. And my run, it goes across by 4. So 200 divided by 4 equals 50. Now my b, my y-intercept, I've already spoken about. That's 400. So I'm going to plug that back in. Y equals 50x plus 400. Now be careful not to leave your answer there because that's not in terms of I and N. I is our y-axis, so I'm going to put that there. And our N is our x-axis there. So we can chuck that in. I'm going to put a little rectangle around it to show it's my equation. And there we go. Okay, so I've got, that was D. I've got E and F. I'm going to do E over here. So for E, use the equation to calculate the weekly income when she has 3 new policies. Well, her income equals 50 times the number of new policies, which is 3. And I'm going to add on to that the 400. So I will equal, well, that will be $550. And last but not least, F. How much does Grace earn for each new policy? Well, her number of policies is N, which means she's getting 50 times the number of policies, which means she's getting $50 per policy. They could have also asked you, what does the gradient represent? It represents the cost of each new policy. Okay. Right, last question. An ultrasound machine was purchased by a medical center for $150,000. Its value is depreciated, which means it decreases, which means it's going to be a negative graph or negative gradient each month as shown in the graph. What was the value of the machine after 40 months? So that should be a nice easy one. I'm going to go 40 months, go up to my line. It's halfway between 80 and 100, therefore it would be 90. But be careful, this is $1,000, so it's $90,000. B, what was the value of the machine after 5 years? Well, 5 times 12 months is 60 months. So I'm looking for 60 months. So I'm going to go from 60 up to get the line. We have, this case, $60,000. C, when does the line predict the machine will have no value? Well, that's when it's at 0. So I go across. That's our x-intercept in this case, which is 100 months. Doesn't ask us for years, so I'm going to leave it in months. D, find the equation in terms of V and T. So y equals mx plus b. Now my m will be a negative gradient because it's going downwards. I'm now going to look for some points that are definitely on my line. That's definitely on the line, and that's that there's definitely on the line. So just be careful about the 2 points you use. You could have used this one here as well. That could have been a good triangle to have used. Or you could use the whole big triangle. Doesn't really matter. But in this case, 120 take away 60 is 60. But remember, that's 60,000. And that goes from 20 to 60. So that's going to be 40. So my gradient is negative 60,000 divided by 40. And I'm going to put that in my calculator, 60,000 divided by 40, which gives me negative 1,500. My B, my y-intercept, is there, which is 150,000, but also that's what we started with at 0 months, which is our initial amount. And so y equals negative 1,500x plus 150,000. Making sure, though, we don't leave our answer in terms of y and x. We leave it in terms of v and t. So 1,500 t plus 150,000. And I like to put my little box around it so I can see that's my formula. Now, E says use the equation to predict the value of the month after 6 months. Well, my value equals negative 1,500 times 6, because it's 6 months, plus 150,000. Equals, and a simple matter of plugging that into your calculator and then seeing what your answer is going to be. And it's also important, like I got 141,000. It's also important just to make sure that that looks about right using your graph. Now, obviously, you're not going to be as accurate on your graph because you can't read between the different values. They're like 20,000 on the v-axis. But it gives you an idea if your answer is about correct. So at 6 months, that's going to be 5. I'm going to look at 5 and see what 5 is going to be. So 5 is all the way up here, which is going to be just above there, which is a little bit below, let's say 145,000. 141,000 looks about right. It's just above that 140, which is correct. So often you might forget the negative, and that would obviously help you to see if your answer wasn't approximately right from the graph, that you may have made a mistake. You can go back and check. Look, I hope this made a bit of sense to you folks. It is a hard part of the topic, the applied questions, but work at it. Make sure you keep going back and replacing it with the letters, because otherwise you will get them wrong. Have a great day. Let me know if you have any issues with these questions.